Hi everyone, in this class we would learn builder pattern. So till today we have learned three creational design patterns. In today's class we are going to learn fourth creational patterns, that is a builder pattern here, right? A builder pattern builds a complex object using a simple objects and by using step-by-step approach here. What is builder pattern here? Here we are going to establish, or we are going to build a complex object. How we are going to build this complex object? Okay, by taking or by gathering simple objects. Simple objects. Okay, so these simple objects can be arranged or can be inserted in the manner of step by step approach. Then we will get a some complex object, right? Okay, this is one kind of building something by taking a simple things. I mean, by taking a simple objects, and we are going to construct or build a big object by gathering a simple objects. So while constructing this complex object, okay, here we are following some step by step approach. Which one we need to take first, which one is second, which one is third, like that, isn't it? So that is the builder pattern concept here. And also this builder pattern comes under a creational pattern. This is the one of the creational pattern method. And this is also one of the best way to create an object. Which kind of objects? Here we are going to create a complex object. This is the one of the best way to create a complex object. So to create this complex object, we are following step-by-step approach. We are involving a simple objects to construct this complex object by following a step-by-step approach here. And also a builder class builds a final object in a step-by-step manner here. And here the objects, whatever the objects we are using, we have used into this complex object, those are all independent objects here. If you want to construct something, okay, we need to gather the different components related to that particular object, isn't it? Those components may be a independent to one with another here, right? And so the process of constructing a complex object should be a generic one. Okay, so what we are expecting from this builder pattern here, the process of constructing an complex object. Which process? Here we are following to construct that complex object is a generic one, so that the same process can be used to create different representations of the same complex objects. Okay, so if you want to build one complex object, then we are going to gather the multiple simple objects or multiple simple components by adding, by inserting those components into one place, then we will get a complex object, isn't it? So whatever the process we are using to insert those components, to make a complex object, that process should be a generic one. That process should be a generic one. Okay, then only we can use, which means what that process may be a simple or step by step manner, and it is a universal It may be a universal acceptable process. Generic in the sense, by following those steps, we may implement more than one complex object, by following the same approaches. Like you may call it as these are the principles or guidelines, principles or guidelines to build some complex objects here. If you will build some guidelines, then many people are following the same guidelines, same rules whenever they want to, okay, build the similar type of objects, isn't it? In such a way, we need to create the what steps. We need to, okay, perform the process to build that particular object here, isn't it? Okay, this is about a builder pattern. Let us see example, then again once again we will see these steps. Okay, this is the example for our builder pattern. If suppose, okay, if suppose my complex object is one laptop. Now laptop is a one complex object. Now I want to construct a laptop. So what I have to do here? I need to take the simple objects to construct the laptop here. What are the simple objects I have taken? LCD display, USB ports, okay, and also some wireless connections, hard drive, pointing devices, battery, memory, okay, DVD and CD reader, keyboard, plastic case. So these are all are the, okay, independent simple objects. Independent simple objects. Okay, by adding these objects, by adding all these objects, and okay, I made one laptop here. This is a complex object. This laptop, this complex object is a collection of, okay, simple objects. By adding all these objects into a single object, right? Clear? So what I need here, if I want to construct a laptop, then this is a, what is the laptop here? It is a complex object. If I want to build a laptop, then okay, I'm in need of all these items. I'm in need of all these the, okay, items. What are those? Memory, hard drive, battery, pointing devices, okay, wireless ports, USB ports, keyboard, LCD display, plastic case. Okay, whatever I'm using into this laptop, these are all called a simple objects. By adding, okay, by adding these all simple objects, I'm going to build a complex objects. This kind of pattern is called a builder pattern here. Okay, if we'll see the first definition. What is the definition of builder pattern here? See, a builder pattern builds a complex object using simple objects. Okay, builder pattern builds complex object laptop using simple objects. Simple objects in the sense parts of laptop here. Clear? And here we are following a step-by-step approach. That step-by-step approach should be generic one. What is this generic and what is the step-by-step approach? Okay, let us see in the same example. Okay, if you will see this example here, how you are going to, okay, insert all these items. Step 1, plug the memory. Step 2, plug the hard drive. Step 3, plug the battery and cover the laptop with plastic case. Everything here we are going to, okay, insert every object in step by step manner. Okay, then only we can we should complete the laptop, isn't it? So this process should be a generic one. Why it is generic one? Which means by following these steps, okay, we may build another laptop also. We may build another laptop also, but that laptop may have some the features may be different. Okay, the features of that laptop may be a different. Okay, the hard drive features may be different, and the memory speed, the memory is, what speed is also a different, and it may use okay different kinds of what capacity parts, but the process should be a same, which means you may construct not only single laptop, multiple number of laptops by using the same process. By using this same process. That's why this process is called a generic process. By following this process, we can construct multiple number of laptops here. But those laptops may be features of different. Okay, the life of battery is different. Okay, the size of the memory is different. And also some hard drive capacity is also different. Okay, those parts, the objects parts may be a different parts, but the construction process is same here, right? So like this, okay, we can build the process, can build the construction process here. Okay, again we'll see the definition. So here what we are going to do with the here, the process of constructing an complex object should be generic one. Then the same process can be used to create different representations, to create different representations of the same complex object. That process may be used for, okay, to build many laptops, not only one, right? So this is about a builder pattern. Clear? Next, now we are going to learn singleton pattern. What is singleton pattern here? This is the one of the singleton pattern. This is the one of the creational pattern. Okay, singleton pattern is the one of the creational pattern. So whenever we are going to build this singleton patterns, here you should ensure that only one instance of the class created here. What we are going to do here we are going to create, okay, only one instance for a class. And like for example, if we have one class, that class should have only one instance. For example, if our class is a shape, that shape has only one instance, which means only one symbol, that is a circle. Okay, if we want to construct a class for a shape, or otherwise if we want to construct a class for animal, if you have a one class, That class name is animal. Okay, so how many instances we need to take into that class? Only one instance. That instance, it may be a lion. Okay, only one instance. What is the class here? The class name is animal. The class is animal here. That has only one instance. Here, the instance name is a lion. Okay, like that, here we are going to create, like that, here we are going to create a class, right? And if we will see the third point, it provides the single pattern provides a global point of access to the object. So whatever the object here we have created, okay, that would be accessed by it's a public accessibility. Here we have providing a public accessibility or global accessibility to that particular object here, right? That is the third point. And if we'll come see the fourth point of singleton pattern, okay, it is encapsulated, okay, just in time initialization or initialization on first use. Here the object initialization is only we can perform only one time. Okay, that is called just in time initialization or initialization on first use. Whatever the object we have created under a class, whatever the object we have created under a class, okay, that is that is okay created or initialized only one time. Next, in software engineering, the singleton pattern is a design pattern that restricts the instantiation of a class to one object. This is useful when exactly one object is needed to coordinate actions across the system. So this kind of singleton pattern is used, okay, whenever we need to create only one object under a class, one time initialization. Okay, which kind of applications support only one object and one time initialization? Such kind of patterns, okay, would construct under a singleton pattern. Such kind of applications would construct under a single time pattern here, right? And application needs one and only one instance of an object. Okay, additionally, lazy initializations and global access are necessary. Okay, after creating only one object, here we are going to, okay, only one time initialization, then here we are providing a global access here. And also here we are going to ensure a class has only one instance and provide a global point of access to it or not. These are the key points under a singleton pattern here. Okay, let us check with example. Okay, I'll explain this slide after the example. Here we are having a example for singleton pattern. If you'll see, this is a singleton class diagram. What it is? It is a singleton class diagram. Okay, the class name is singleton, and here we are having, okay, the instance name is also a singleton, only one instance here. How many number of instances are there here? Only one. And this instance has some what symbol. What is this symbol here? Some minus symbol. Minus symbol indicates it's a private one. What it is? So plus symbol is used for public, minus symbol is used for private access, public accessing and private accessing, isn't it? Which kind of symbol here we have used? Minus. So this singleton is a private instance here. What it is? It is a private instance here. And also, okay, here we are having one constructor. This constructor is also a private one. Here we can define one constructor singleton. This is a constructor here. This constructor is also a private one, right? And also, okay, here we are having one more method, get instance method. Get instance method. This get instance method has a plus symbol, right? It is a public access, which means it means it can provide a public access. Get instance. This method is called a get instance method. Through this method, we are having this singleton return type here, right? This method this method only first time it will create if we are not initiated, or if we not created this singleton instance, then it will be created this singleton, okay, object whenever we call this get instance method first time, for the first time. Okay, second time onwards it will return the same, okay, data or value, whatever the first time, whatever the things we have assigned to this particular singleton object. Okay, second time onwards we are just using or accessing the same things from a JVM mission. We can't modify the data. Okay, only one time creation of this singleton instance, and that should be saved into a JVM mission. Okay, if we want to access this data multiple number of times, second time, third time, fourth time also, it will return the same data. We can't modify that one. Clear? So this is the method whichever we have defined under a singleton class diagram here. And also here we are having three specific rules for this class, okay, definition under a singleton. How many number of rules here we are having? Three rules under a if you want to create a singleton class, then you must follow these three rules here. Okay, what is the first rule? First rule is a static member. Whatever the instance we are creating under a singleton class, that is a static member. So to represent that static member, or it's a private member, for that only here we are using that this kind of symbol. So the singleton instance is a static one, static member, right? And if you'll see the second point, private constructor. The constructor here we have, okay, we have used one constructor, singleton constructor, isn't it? We have created one constructor here. So which kind of constructor it is? It is a private constructor. It is a private constructor. This will prevent anybody else to instantiate the singleton class. So it is restricted. Nobody, okay, this constructor, whatever the constructor here we have created, that is a, okay, private accessibility, which means only this singleton class is going to access these values. Okay, no other classes can access this constructor data or values here. Okay, so no other class instantiate this singleton class here. Why? Because it is a private constructor here. It is purely accessed by this particular class only, isn't it? Next, coming to the third key point is here, static public method. Okay, static public method. So here whatever we have defined, one method, we are having one method, get instance method is there. So this provides a global point of access to the singleton object and returns the instance to the client calling class. Okay, it will return to the singleton what instance whenever the client is called, whenever the client is accessed this get instance method by using a by using a singleton class. So if it is a first time, automatically it can create this singleton object. Okay, next time just it will return the objects whatever it will return that object, that's it. We can't modify the data, we can't modify the data, right? So that's why it is a static public method. Which kind of method it is? It is a static public method here, right? And and next, the singleton, this is the main class, this is the main method. So this is a singleton, this is the part of at the part of client. Okay, so client is accessed from this main class here. Whenever the singleton pattern, this is the class name singleton pattern demo. So through this main class, he is going to access this singleton class here, or singleton, so not the class, singleton get instance method here. He is going to singleton dot get instance method. Okay, this is the client part, right? This is part is the client part. Whenever the client is calling, automatically the get instant method is executed. First time it is created, second time onwards the same thing whatever the stored in JVM machine, it will be returned to a client, the same outcome. This is the uh, example, one example for a singleton design pattern here. And again let us discuss the points, okay, under a singleton. So whatever we have discussed in singleton pattern, the first point is, okay, the first point is the singleton pattern, it ensures only one instance of a class. We have seen that that is a singleton. The same instance name is also a same singleton. Okay, it provide a global point access to the objects, which means get instance method is a global access one. Through that method, okay, we can access that object, right? It can be saved in into a JVM, and it is initialization is only first use. We can initialize that object only first time calling, second time, third time, fourth time for calling, like that we can access the data also. Just it will return the data whatever it has, that's it, isn't it? And here we are having some more points about the singleton pattern in next slide. So these are the some other few more points related to a singleton design pattern. The singleton design pattern is a design solution where an application wants to have one and only one instance of the class. Which application wants only one instance of the class? Okay, for such kind of applications only, it is a one kind of design solution. It is a design solution for the applications which applications need only one instance under a class, right? So after that, already we know that we can access the singleton instance, we can access the access provision is there. Okay, we can provide the global access for that particular instance here. And also it ensures there is only one instance of a class created in the JVM. Okay, so only one instance of a class is created in the Java virtual machine, right? And the singleton patterns are used in logging, caches, thread pools, configuration settings, device driver objects. These are used in logging, caches, thread pools, configuration settings, and device driver objects. If suppose there is a configuration settings for mobile or for laptop, assume that only this configuration settings can be created only first time. Next time onwards, we are using uh, uh, the same configurations, isn't it? So for such kind of things, such kind of applications, we are going to use for such kind of applications, this singleton pattern is suitable. And also this design pattern is often used with other other factory design patterns. The singleton pattern can be okay used with other design patterns, that is a factory design pattern here. Okay, and this pattern is also used in service locator JEE pattern here, right? This is about singleton pattern. Clear? Next we are going to discuss about structural design patterns. Okay, this till now we have finished off 5 patterns under a creational design patterns. Okay, so now we are going to discuss about second category of okay, second category of design patterns. Those are the structural design patterns. Okay, first one is the creational design patterns, structural design patterns, and behavioral design patterns. These are the main design pattern catalog of design patterns. Okay, under that first one is finished. Okay, now we are going to discuss about a structural design patterns. This is the first this is the concept under a first chapter under a fourth unit. Now we are going to start our fourth unit, isn't it? So structural design patterns are the first chapter under a fourth unit. Behavioral design patterns are the second chapter under a fourth unit. Clear? So let us discuss about a structural design patterns now. So the structural design patterns are concerned with how the classes and objects can be composed to form a larger structures. If we want to build larger structures, how the classes and objects are involved into that particular larger structure here, or how we are going to change those classes and objects if we are need to construct the larger structures, isn't it? Okay, and the structural design patterns simplifies the structures. What the structural design patterns will do, those simplifies the structure by identifying the relationship between classes or between the objects. So it can simplify the structure by identifying the relationship between the classes or objects here, isn't it? And coming to the, if we can see the third point, these patterns focuses on inherit how the classes inherit from one class from another class here, right? Here how one class is inherited from the other class, right? This is about a structural pattern, structural design pattern. The structural design pattern would be concentrate on structure of a, okay, structures of a classes or structures of a project here. What is the structure here? Structure in the sense it's an architecture, isn't it? How the classes and objects are converted into a structures here, right? Structure in the sense it's maybe a design, maybe a design, right? Now we are going to discuss about the types of structural design patterns. Now here we are having, there are 7 types of structural design patterns are there. The first one is adapter pattern. Okay, adapter pattern in the sense by using this design we are going to match interfaces of different classes. Okay, here one class interface may be one type, another class interface may be another type. How we are going to, okay, connect these two classes? How we are going to connect two different classes? Okay, that so that this kind of things would discuss under a adapter pattern. And bridge pattern, in this bridge, second one is a bridge pattern. Bridge pattern separating abstraction from implementation. Okay, it separates the abstraction from a implementation, right? And composite pattern, this composite pattern is about it allowing the clients to operate on hierarchy of objects. This composite pattern is discussing about a hierarchy of object, how we are going to construct the objects in a hierarchy manner, and how to deal with those objects here. And coming to the fourth one is a decorator pattern. This decorator pattern is adding functionality to an object. Okay, adding more number of functions to a particular object. How we are going to add those functions to a particular object? Okay, to improve that to improve the performance, or to improve that some appearance, etc., right? Next, fifth one is a facade pattern. So this facade pattern providing an interface, okay, to a set of interfaces. It provides a single interface to a set of interfaces here. Next, flyweight pattern, it reusing an objects. So this pattern would concentrate on, okay, reusing of objects by sharing. How we are going to reuse one object? Okay, through sharing only, no? So that's why these are the flyweight patterns. And coming to the last one is a proxy pattern. This proxy pattern is about representing another object. Okay, we are going to represent some another object. This is the last one. In next class we are going to discuss about, okay, one by one. Here we are having 7 patterns are there. Now these 7 patterns would discuss in detail in next class. Okay, thank you.